Here I am demonstrating how to solve this particular problem using ANSYS APDL. So this is a cantilever beam which is fixed at one end and we are applying a load of 250 Newton at the other end. So here I will be demonstrating the same problem using a 1D element as well as a 3D solid element. So for that, first let us go into the ANSYS APDL launcher. So for that you have to search for ANSYS Mechanical APDL product launcher. So you will be getting a window like this. Here working directory is the place where all the files associated with your simulation will be getting saved. And you have to give a particular job name also. So let us go to run. So this will be running parallelly and the new window will be getting opened. It may be taking some time to open the launcher. Okay, now the window is opened. So this is the main window of APDL. Here basically we have to go through each of the options which is listed under the main menu. Okay, so first let us go into the preferences. So before going that, I would like to tell about the unit system in the APDL. Here, unless we are choosing anything from the material database or something, the system is not following any particular unit system. So whatever the unit we are defining or the numbers we are taking, the system will be giving us the result based on that. So either you can go for all the datas in SI units, or you can select the dimensions like a unit of length as mm. Then accordingly you have to select Young's modulus and other strength parameters in megapascal. Okay. So first we have to go to the preferences option. Here we have to choose the type of analysis which we are going to do. So we know our aim is to determine the deflection and the axial stress of this particular beam. So we have to go for a structural simulation. So check the structural simulation and press OK. Okay. Next we have to go to the preprocessor. Here element type. Here we have to select an element which is listed in the APDL. So for that click the first option, then click the add option. Here a lot of elements are listed. So for this particular problem, since first we are considering it as a one-dimensional case, we have to select a beam 188 element. So go to beam. Here two varieties are available. We have to go for 2 node 188 option. Just press OK. So this particular element we have taken has listed under this table. Now press close. Now since we are defining it as a one-dimensional geometry, we will be representing the beam as just a line. So we have to define a section for this beam which is representing the cross-section of this particular cantilever beam. So for that, okay, now we have completed the element type. Now we can go to the section option. Here section library, it will be available in existing section we can choose, or we can construct our own. So here we want to make a beam element, so go into beam. So here some of the sections will be commonly available, or we can make our own sections. So probably we have to make a rectangular cross section, so it will be mostly available. So just click common section. Here one subtype rectangle is listed out, so that this is what we want. Okay, here one thing to note down about this this particular rectangle is here B and H orientation we have to taken care. As per our problem, here B width is 10 and height is 20. This we have to give in inverse opposite to whatever our problem we have to give it in the ANSYS, which means here in the comment section, sorry, I think that window is hidden somewhere. Yeah. So here in this, they have shown that the width is B and height is H. So as according to our problem, width is 10 and height is 20. But we have to type it in reverse manner. So width is 10, instead of that we will be typing width as 20, and height is 20, instead of that we will be typing height as 10. Just press OK. Sorry. Yeah, this is our main window. So now we have defined the section. Okay. Now after that we have to choose the material. Yeah, or you can choose the material before itself, it won't make any difference. So go into material properties. Here we have to go for material models, I think. Yeah, we have to go to material models. Here we have to create a structural model which is linear and elastic. Also it is an isotropic material. So we have to type the Young's modulus and Poisson's ratio values. So Young's modulus, okay, here in this problem I am going to choose all the length unit as I am taking as mm. So Young's modulus I have to type in megapascal. So the given value is 200 gigapascal. So we can type, it will be 2 into 10 raised to 5 megapascal. And Poisson's ratio for the steel in the problem it has given, it was 0.3. So we are typing those values also. Press OK. So we have defined the material now. Now we have defined the material as well as we have defined the element type. Also we have defined a section. Now we have to model the section. Here we are creating the particular beam. Here ideally we have to just create a line. So line itself we can create in multiple manner here. Either we can type the we can create two endpoints of a line, then we can join it, or we can directly make a line by giving the coordinate like that. Here I would like to create the line using this endpoints. Here it is known as key points. So go to key points. So on the working plane, yeah, in this plane we have to create. So just click on working plane. Oh sorry, we can go into inactive CS. Both will be giving us the same result only. So here I am typing my first key point. I am just giving a number as 1. I want to start the line from the origin. So 0, 0, 0. This will be my first point. Apply. So here we can see one point might have created here actually. Now we have to make a second element. So type 2. So here we know the the length of this particular beam is 200 mm. So let me check. Yeah, it is 200 mm. So we have to type 200 and 0, 0 because we don't have any particular value in y and z. Press OK. So here 2 points might have created 1 and 2. Now let us go into the line option, and we have to make a straight line. So they are asking us to choose a key point for them to draw a line. So here we are choosing first line. So here this particular thing will be coming in handy sometimes. Here if you want to select something, always select this pick option. If you want to deselect anything, go to unpick. Now we have selected one. Suppose if I want to unselect it, just unpick and click. It will be unselected. So here pick, we are selecting the first element and the second. So by default the line has came. Right. Now just press OK. So now here we have created the required line. Now let us go into mesh and let us mesh it. Here we don't have to do anything. Okay. Here one general thing about this ANSYS APDL. Under each section the creation as well as edit as well as delete option will be provided. For example, here under section you can see there is a section creation option as well as section delete option. Here now we have modeled it. Suppose if you want to edit the model, the create option, under the create option only we created right now. You can do any operation like extrusion or something under operation, and if you want to delete, you have to go for this delete option. So if you want to delete the key point, go to delete option. Under that key point line, everything will be listed out. Okay. Anyway, now we are going to mesh. Here we can directly choose the mesh tool. That will be more easy than going through the other options. So here let us first directly go into the mesh tools. Here it is. Here according to the requirement we can choose whatever we want. So right now we know that we have to just split this line into different parts. So first I am just solving this particular problem by considering 4 elements in this case. So I am choosing line. Here we are selecting. So when I click that, here this particular option came. Here they are asking us to choose a line. So here as before, either you can go for single selection you can do, or if it is a different body, when you can go for this box selection, you can select like this. Okay, now I should unselect it. Now suppose if you feel that you did some mistake during this operation, just reset it. You can just select it again. If it is causing any problem, again reset it and single. Yeah. So now we have choose the particular line. Okay. Now they are asking in how many elements we have to split it. So the mesh size we can either define by providing the element length or by giving the number of division. Now here we know we want to split it into 4 pieces. So the total length of the beam is 200. So which means each of the element will be 50 mm length each. So either you can type 50 here or you can type number of element division as 4. Both will be giving us the same result. Okay. So here it has splitted into 4, but still we did not mesh it. So for that, again go into the mesh option. This dialog box was already there. Go to mesh option. Then it is asking which element you want to mesh. So we know either you can pick everything or you can just directly go into this pick all option. So it will be picking whatever available in this window. So I went for pick all. So whatever split we have made, they have meshed all those things. Now we don't need this particular window anymore. So we can just close that. Okay. Now here we have completed the meshing also. Now our remaining task is that we have to apply the boundary condition and we have to start solving it. All these are given in this particular solution. It is, even though it is available in load, I prefer to choose this load option under, which is listed under the solution tab. So go to solution. First we have to choose the analyze type. So click the analysis type, new analysis. Here we know we have to do a static structural analysis. So select static and press OK. Now second we have to define the loads. So for that click this option. Here under this load we can see apply option. Go to apply. We know it is a structural load. So go to structural. So here we need to define two conditions. First thing is the left side of the beam was fixed boundary condition, and at the right side we are applying a particular force. So first I want to arrest the displacement at the left side, so I am going to select displacement. Under displacement I know I want to select this particular side, a particular point or a node. So either I can go to key point option or I can go to node option. Both will be giving us the same result. I am clicking the node option, then I am clicking the first node. Okay, then press OK. So here it is asking what are the boundary condition, what are the displacement I have to give. So here it is written that degrees of freedom to be constrained. So here for a cantilever beam the end will be fully fixed. So we have to constrain all degrees of freedom. Press OK. So we have constrained all degrees of freedom. Here you can see some particular symbol has appeared, which is representing that all the degrees of freedom are constrained now. Now again we have to apply particular force. So go to the force bar moment option. Again I am applying a node. I know I want to apply the end node. I am selecting the node here. Press OK. So here it is asking the value. Here as per the question we have to give 250 Newton force downward direction. So we know it is Fy and it is a constant value. It is downward, so minus value is 250 Newton. Okay. So here we can see a force has also created. So now we have given all the required data for this particular problem. Now we have to just solve it. So for that, just minimize these options. So under solution itself you can see solve option. So click on the solve. From current load step, just click the value, click the button, press OK. It is solving now. You can go through these details also if you want. Yeah, solution is done. Close. Now we have solved it. Now we have to view the solution, view the result. For that, go to this. Now initially we have given the preferences, then we have given the element type etc. in the preprocessor. Then we have given the load, force and everything in the solution option. Also there we have selected the type of analysis we have to conduct. Then finally we have to view the result. For that, go to general post process. Click that. Here too many options are available. Here we know we have to read the result. So read results. From first set we have to read. Then at the down you can see plot the result. So click the plot result. Here if you want to see the deformed shape, here we know that if you are applying a load like this, the beam will be deflecting downwards. Let us see how it looks like. So go to deformed shape, Here we want to see both deformed as well as undeformed shape. For a comparison, select it and press OK. Yeah, as per our estimate, it has have a downward deflection. Now if you want to see any particular data, we can go to list results. You have to go to plot results itself. Here contour plot you can see. Under contour plot you can go to nodal solution or element solution according to our requirement. So here my interest is to find the edge, the endpoint deflection as well as axial stress. So I'm going to nodal solution. There I know in degrees of freedom. Here the type of element which defined was a beam 188. So its degrees of freedom will be displacement only. So under degrees of freedom you can see all sort of displacements are available. Here my interest is to find the y component displacement. So click y component, press OK. So here it is showing the particular value. Here we can see the maximum deflection. Here even the size, because the direction is downwards, the end deflection direction will be negative. So that's why it is reading under the minimum. But the end deflection will be 0.497554. Unit will be mm. And if I want to find the nodal stress instead of that, or the axial stress, go to nodal solution again. Here instead of degrees of freedom, you can choose stress. My interest is x-axis stress. So select x-axis component, press OK. Here it is showing, okay, here actually it is not showing the result. Okay, so for that we can go to plot option. Okay, this particular option, this plot bar, replot is something like a refresh option. Go to plot controls. Okay, here I was just showing this option is available there. Here for us to view this in the deflection, one option is go to plot controls, styles, edge options. You have to go to plot controls, style, size and shape. Check this particular thing. Okay, so here it has came in that color format. Here now it is written that what is the maximum x-axis deflection and everything. Okay, so here we have solved this particular problem. Now suppose if you want to change the mesh of this particular thing to redo the simulation and everything, we can do that again. We have created the mesh under pre-process. So go to pre-process, mesh tools, line. We know we were having one line here. Click that, press OK. If instead of 40, suppose if I want to make 40 elements, 40 elements, type 40, press OK. Since we have changed the number of elements, we have to mesh it again. So click mesh, select pick all. So it is telling that already one mesh is available, so we have to remesh. Okay, so it is telling that it is not possible to remesh. We have to clear the mesh before doing that. Okay, so let us clear the mesh first. For that we have to do, okay, here clear option is available. So click clear, pick all. So it has cleared all the mesh. Now we have defined the lines. Okay, let's define it again. Click it. Okay, now you can see it's actually split into 40 pieces, so we don't need to define it again. We can mesh it, mesh, pick all. Yeah. Now it has meshed. If you want to just refresh it, replot, you can see. Now we can just rerun the simulation. Okay. Here, since we have applied our load as well as the boundary condition at the extreme nodes, mostly it won't be getting affected by the remesh. But suppose if you are confused and if you would like to again redefine the loads, we can do that. For that, go to solution option. We have applied load in the we have applied load in here, define loads. Click define loads. Here first we have to delete whatever we have given. So all load data we can delete. Then we can apply that load again. Click apply displacement on key points or on node I have to give. Select the first node. Okay, all degrees of freedom I want to arrest. Press OK. Then select force. Select the last node. OK. Here Fy 250 Newton I have to apply. Press OK. The value is given. Now we have to just solve it. solve, current ls, okay, solution is done. We can see the result. General post process, read result from first set, plot result, deformed shape, deformed and undeformed shape. Here we can see the deformation. Go to nodal solution and degrees of freedom. We know y displacement we want to find. The maximum value is now given as 0.5. Now if you want to find the stress, again go to nodal or element solution also you can go. Stress, x component of stress 74 Newton, stress will be Newton per mm square or megapascal.